Cisco Certified Network Associate, Day 1. Welcome back everybody. I am Imran Rafai, your trainer for this entire series. Today we would be starting with network fundamentals. And when I say fundamentals, we would deal with the very basic of the networking industry. So this video ideally is not only for the people who are going for the CCNA certification, but anybody who is interested to or looking to start a career in networking. Feel free to watch this because you are going to learn a lot. But CCNA as a certification, it's a very valuable certification, and I urge everybody to go ahead and take that certification because it is gonna add a lot of value. Before I go any further, I would ask everybody to concentrate on the first 3 days of our video, because we would be covering a lot of very basic concepts, which, if I can dare, I would say it is going to be the base of your entire networking career, maybe even 20 years from now. So please concentrate and be clear with every concept we cover here. And in case you still have doubts, please feel free to email me at imran.rafai@nwking.org. That is imran.rafai@nwking.org. Alright, without further ado, let us get into our video. Let's start with the very basic question: what is a network? Well, whenever I ask this question to my students, more often than not, I get answers like Facebook, Twitter, Picasa, whatever that you see here on the screen. But, well, that is social network. That's not the network we are here to learn. And that definitely is not the network I am going to talk about. What I am interested in is this network, the network between computers. Well, this network is also the foundation or the base on which applications like Twitter, Facebook, Picasa, whatnot is built on. So we will learn about this network, and maybe if we have time over the course of this series, we will also talk a little bit about those applications here and there. Right, when I was preparing for this video lecture, I was preparing this image that you see in the screen, and I was thinking, okay, let me see how do I explain this concept to students who are starting on the networking industry. So how do I explain this concept without actually using a lot of technical terms or saying, okay, this thing communicates with that thing over this thing? I mean, it was difficult, and then I thought, okay, I need a better way to explain this. And I remembered a story that a teacher of mine told me when she taught me networking. It's about the olden days of how kings exchanged messages with the ally. They would pass the message to a messenger who used to ride on horsebacks, and they used to go through all these, the paved path along the roads, and then they used to go through the city gates, and then they used to go to the other king and deliver the message. So if you compare that to a computer network, the messenger sending the message, so the message is like the data that you send. Data could be anything. It could be a doc file, a Word document, or it could be an Excel file, it could be an image, it could be video, it could be anything, the data. And the road on which the messenger traveled, that basically is the network. Of course, computer network is much more interesting than just paving roads. But if you see, that is the very reason why computer network is invented, to communicate between computers. Now, if you see this image, you would see, let me just take a highlighter. You will see that we have the Windows PC, we have Linux systems, an iMac, and we have a laptop, mobile phone, Palm top, you have web servers, maybe it's running on CentOS, You have database servers, file servers, but in spite of they all running on different operating systems, they all can communicate absolutely perfectly with each other. This is the magic of computer networks. The computer network runs on a global standard called the OSI models and things like that, which defines clearly what, when any manufacturer manufactures a networking device, what and how they should communicate with each other. So they all know the language of networking, and that enables them to communicate with each other. Let's try to break this a little more further and see how internet works. So if you look at the picture on your screens, this is the very basic network. Two computers connected with a wire. In this case, we will use a Cat5 cable. A Cat5 cable looks something like this, and this has, they come in different colors. You have the blue color ones, red color ones. I mean, this is obviously another color, and the outer cover is just a protective layer. Inside you have 8 tiny cables. These cables go into a connector called the RJ45 cable that looks something like this that you see on the screen. And on the back of your computer, and most of the computers that you have today, you have a port, a port like this. That is your interface, your network interface card. So your network interface card is where this RJ45 connects, and using this you can communicate, these two computers can communicate with each other. This is the very basic form of networking, and this is called as Ethernet. E-T-H-E-R, net, Ethernet. Let me just write it down. It's sorry about my handwriting, and it's very difficult to write on screen, especially with my mouse, but let me just Ethernet. Maybe for my next video I'll buy a stylus so that I can just write it more legible handwriting. Alright, but for now, yeah, so this cable connects between these two computers, and you can have a very basic networking. But what happens if you have more than 2 computers? So let's say you have 5 computers. I mean, you obviously there's one way, obviously you can go on adding more networking interface cards on your computer, then you can have. But a better way of connecting is by making use of a networking device, maybe a switch or a hub. Of course, switch and hub are 2 different devices. They have totally different functions. We will obviously learn about them in future video episodes. But for now, you know, we have a networking device. In this case, it's a switch, and these computers can communicate with each other. So for instance, this guy is got a Word document that he wants to send across the network to this guy. All he has to do is send it across to his IP address. What is an IP address, you would ask? IP address is how computers recognize each other on the network. We will learn about IP addresses in the next video series, but for now just know they are identifiers for computers. Another critical reason of why people use networking is because of devices like this. You know, maybe let's assume that this was a very expensive printer or scanner that the company invested in. If networking was not available, the way this device would be connected is to this. Okay, let me just change the color, just show that it is okay, let's use black. So this is, it would have had to be connected directly to the computer. Now let's assume that this user maybe prints 1 page a day, and maybe all the users in this company has similar requirement that they have to print 1 or 2 pages every day. So the company will have to invest on more printers. So you'll have 1 more printer here, this guy will have 1 more printer. So company will have to unnecessarily invest on a lot of printers when the usage of them and all these printers are going to be very, very minimal. Better way for companies to invest money on IT infrastructure is to have one printer, very expensive, good quality printer, plug it onto the network, and everybody can print to it. That's a lot of money saved, and that's a very efficient way of using IT budget. So that is the very basic requirement and the reason why we have computer network. So a computer network in a local office, maybe one home office in a room, in a single company, that's called as a LAN, local area network. And local signifies that it's very local to a geographical area. If this same local LANs, now these are LANs, and you have another LAN here, and let's assume that your company has two offices, one in New York and then you have another office in Boston. One way you could communicate, create a network between the two offices of your company is, of course, if you had the kind of money that is required to cable from New York to Boston, and of course if you can get the permissions, you could run your own private cable from your Boston office to your New York office, no problem at all. But not many companies have that kind of money, and not many companies would like to waste that kind of money. We have a better way of doing it. You could connect your office to a local ISP. ISP is nothing but internet service provider, and the similar thing happens on the other end. Boston connects their office to an ISP, internet service provider, and ISPs already have their backbone, very massive high bandwidth connections between their offices. So your data that you send from here goes through the network, through the ISP, from ISP to the ISP in Boston, and then through that they go back to the Boston office and a computer. So this computer can communicate with this computer absolutely fine using the ISP. Now this forms the wide area network, where LANs are interconnected with each other to form a very wide area network, and wide here signifies a wide geographical area. It could be across the country, it could be in different cities in the same country, or maybe in different countries. Basically it's a WAN. So that is how it works. Now how do you connect from ISP to your local area network? How do you connect to the ISP? Well, normal situation, what happens is you get a jack on the wall. You might have a small jack on the wall, and your LAN you just connect it to the jack. So from the switch, from the router of your company, you connect it to the jack. The back end, this ISP, they would lay cable. Maybe they would lay it under the ground. They lay a cable to their office, and from their office they go here. From their office again, maybe underground, they lay a cable to the Boston office. Again, there will be a wall socket that is provided, and you just plug a cable from the wall to your router, and that's how your WAN link works. Well, this is also internet, because we're using the ISP. Internet is nothing but a very massive WAN which covers the entire world, where you have a lot of public resources. So if you Google, this is the definition of what an internet is: a global computer network providing a variety of information and communication facilities, consisting of interconnected networks using standardized communication protocols. Whoa, that is a big definition. Well, that's exactly what it is. Internet is nothing but you have a lot of WANs. So you have a WAN here, 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 and then just WANs are connected with each other. So you have another WAN here, and you have another WAN here, another one here, another one here, maybe a few more here. I know in India there are quite a lot. You have all these things and they are connected. Let's, for instance, you're connected from here, it's connected here, from here you're connected here, this is connected, this is connected, this is connected, this is connected, this is connected. So this is nothing but how an internet works. So for instance, if from India somebody has to communicate to New York, this is how the data will transfer. They will go, if this thing disconnects, you will have the data going through a longer path. So this is what a network internet is. It is just nothing but interconnections of a lot of WANs. Let's find out more about the applications we were talking about earlier. There are a lot of usage of the internet or networking as a whole. We have YouTube, CNN, eBay, Skype. This is just very few examples that use the internet, but there are a lot of sites and applications which use the internet, as you already know. Now how it works is, YouTube for instance is owned by Google. So Google has put a public server somewhere on the internet that is accessible to anybody on the internet. So if I want to watch a video on YouTube, I go to my web browser and type www.youtube.com. The process that takes place in the background is much more complicated. I'm just simplifying this whole process. We will look into exactly how it works in further video series, but for now, when somebody types youtube.com and hit enter, my computer sends a HTTP request to YouTube's public server. When the server gets that information, it says, fine, that's an HTTP request, so I send an HTML file back. So it creates an HTML file back and it sends that HTML file back to me. My web browser takes that and says, that's an HTML file and I know how to process it. So it processes that and your YouTube website comes live and you see that. It shows a lot of videos and you click on one of those videos, this process repeats, they send you back the video, and that's how that works. So similarly it happens to eBay, you go to CNN, Skype, that's how it works. So this is how internet works. Basically they have a public server, they put all the files there, your computer requests that, they send the file back to you. And this is how internet helps you run this globalized world. When we talk about internet, very critically we need to talk about the speed of internet. Before we get into the speed of internet, let's get to what is the difference between bit and byte. Bit is the smallest information computer can understand. It's either a 0 or a 1. Whereas byte is nothing but it's formed by 8 bits. So 8 bits together form 1 byte. It could be something like 1 1 0 1 1 1 0 1, whatever, something. So that's a byte. So 8 bits form 1 byte. Now a lot of people get confused. Data is always denoted by bytes. So when I say I have 1 GB of RAM, it is 1 gigabyte of RAM. But when I tell I have a 10 Mbps connection, it is 10 Mbps connection, bits per second, megabits per second connection. If you confuse these two, it's going to be very, very difficult. At 1 Mbps, byte per second connection is 8 Mbps connection. I mean 8 times the speed of what it is supposed to be. So speed is always denoted by the small b, data size is always in big B. In computer world, kilo is always 1024. So 1 kilobit is 1024 bit. Similarly, 1 kilobyte is 1024 byte. Right. So for instance, let me see, I have a 1 Mbps connection and I have a file of 128k bytes. So let's say for instance you have Word, and in Word you type the alphabet A. Now with to produce that one alphabet, that takes about 1 byte, capital B, of space. So 1 byte is how much it needs to store this alphabet A. 1 byte is about, it is 8 bits, right, according to the conversion. So to type A, it takes 8 bits or 1 byte of data. Alright, having known that, let's look at this example. So you have 128 KB, that is byte, a file of 128 KB. Now it needs to go across a network with speed of 1 Mbps, 1 megabits per second. How much time will it take? It's a very simple question. Let's try to convert. 128 kilobyte, if we convert into bits, it is 128 into 8. This conversion, if you know, bit, byte, it's 8, right? So 1 byte, 128 byte is into, if you convert it into bits, it is 1024 kilobits of data, right? So 124 kilobits, where is that? It's here. 124 kilobits is nothing but 1 megabit, right? 1 megabit. What's the speed? It says 1 megabit per second is the speed of our connection. So on a connection of 1 Mbps, it 1 MB file will take exactly 1 second. So that's what speed is. So understand this, the difference between speed and data, the difference between bit and byte. So if you can understand the difference between bit and byte, the whole process of understanding further videos is going to be very, very easy. When we talk about speed, we need to also talk about 3 other critical factors: that's speed, delay and availability. 3 of them always go hand in hand. Like for instance, now when you connect a cable from your router to your PC, it tells you that it's connected at 100 Mbps. That's because today our LAN card, the maximum they can do is 100 Mbps. But then don't forget that speed that they're telling is the speed between your computer and the router. Your internet connection may be a 1 Mbps connection. So if you send 100 Mbps data, 100 MB per second data, it will not go through your internet, because your internet can only do 1 Mbps. Similarly, you go let's say for instance this is your Bangalore office to your New York office. We are sending a file. So from Bangalore office it goes through a gateway. From gateway we have a 1 Mbps slow connection. It comes to our Bangalore ISP. Bangalore ISP to Mumbai ISP, they have a 100 Mbps line, very fast. And then from Mumbai to Dubai they have a 10 Mbps line, a little slow connection. From Dubai again to Cairo they have a 100 Mbps line, and then Cairo to Madrid, let's say you have a 100 Mbps line. So similarly they have a smaller, higher, different speeds around the world. So basically when I say net to internet, this is what happens. Internet, if you pull off the cloud, it is nothing but a lot of routers jumping here and there. Now even if I have a very high speed connection, your data throughput between your Bangalore and New York office will depend on slower connections in between. So even if I had a very high speed connection, a 100 Mbps line in Bangalore, right, it can only travel at the slowest link in between. So our slowest link is the 10 Mbps line that we have here. So from New York office to Bangalore office, it will always, the maximum it can do is the 1 Mbps line that we have in New York. So this is how it works. So I mean, this is not the exact data flow from Bangalore to New York. I've just giving an example. It need not always go via Dubai and Cairo. Maybe it goes through some other location. But basically it actually, the data packet flows through one location to another location to another location it goes. So like I said, the speed always depends on different factors of the link speed that you have in between. Again, there's a critical factor is of delay. Now when I send the data from New York to Bangalore, it has to, like we already discussed, it has to pass through a lot of nodes in between. But let's assume that we have another office in Boston. I love Boston, don't I? So let's say we have Boston office, and we send data from New York to Boston. It has to pass through less number of nodes, and hence it would reach much more quicker. So that's another factor. If the distance between the two devices is long, you will have delay in the communication. And that's why today if you go to Google, I mean even google.com for instance, or you go to youtube.com, they redirect you to a content delivery network closer to your place. So if you are in Singapore and you say google.com, or you go to youtube.com, the YouTube would not connect you to the Google server or the YouTube server in the United States. It will connect you to a content delivery network close to Singapore, maybe in Singapore, so that there's not much delay, or there's insignificant delay in the communication, and the whole process is much more fast. So that's the delay part of it. And the availability, again, for instance, the link between Cairo and Dubai is done. Communication between New York and Bangalore would not happen, or it would happen, but then it has to take maybe a longer path. You might have another path which goes via Russia, and then it comes via it goes via China and comes to India, and it's a long process. So that's another thing about availability. Availability is if all the links in between are up and running. Another thing we need to discuss in today's video is network topology. The network topology, there are three fundamental network topology: the star topology, the ring topology, and the bus topology. The very olden ways of how computers were connected, but even in today's world they are in use. I will show you how. Now, for instance, star. How does star work? Star is where all the computers or devices are connected to a central switch or a connecting device. Now, if this line goes down, it doesn't affect everybody else. Only this guy goes off the network. So in ring, for instance, every computer is connected to each other. So if this guy goes down, the communication between these two devices can still happen through this way, right? So that's how this works. Now in bus topology, let's say for instance, this is again like that. You have a device here, this is connected to this device, you have another device here, that is connected to that. So every computer is connected to their own little device, right? Now if the link goes down here, this part of the network can communicate with each other but not with another device from the other segment of the network. That's how a bus network works. Let's see how it is implemented in today's world. We go back to our old example that we saw earlier in this video, and if you see, this switch and these systems or these PCs are connected in a star formation. Everybody is connected to this central switch. Here the server also, similar thing happens. Everybody is connected to the switch. These devices are connected to the access point in star formation, or and so to say. And if you look at the switch is connected in a bus formation. Now if the link goes down here, this part of the network can communicate with each other, but it cannot communicate with anybody else from this part of the network. Sometimes you might even have networks where this is connected like this and this is connected like this. So even if this goes down, the switch can still access this network around this path, and they can get access to these windows, these systems here. So in real world, the network topology that we use is called hybrid, which makes use of the star and the ring, and maybe even the bus. So it's a combination of all the three or either of them, and that's how it is. So it is a hybrid network that we use in today's world. I think that is about all the information that I wanted to speak about in this first video. We will further get into a lot of other topics in our second video. This is the review of what we did today. Go through all the topics that is mentioned here and see if you understood any. If you didn't, you can always go back and try to learn a little bit more. And even after that, if you have confusion, if you want more clarity on any topic, please feel free to write into imran.rafai@nwking.org, and I will look into it and I will answer your queries. And of course, subscribe to our YouTube channel, and you can keep getting all our videos live on YouTube. Thank you for watching, and please visit our website. Bye.